Assalamu alaikum. This is Kamrul Hassan, lecturer, Department of Mathematics, Milestone College. My dear students, I hope you are fine and safe at this present situation. Our today's topic, basic discussion about permutation and combination. First of all, I want to discuss basic formula about permutations and combinations. First one is permutations. What is permutations? Each of the different ways of arranging objects taking some or all at a time out of a given object is called permutation. The number of permutations refers to the number of arranging in order taking r objects at a time out n objects. So here n and r positive integers number and one condition is here n is greater than r, which is mandatory condition for permutation. And now the number of permutation of n objects taken are at a time denoted by here n p r or n p r or p of n comma r, p of n comma r. Now for example, such as taking 3 at a time out if letters here A, B, C, 3 letters here. Taking 3 at a time out if letters A, B, C, here we can write A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, and last one is C, B, A. Here total number of arrangement is 6. Total number of arrangements 6. If we take 3 out of 3, that's mean 3 permutation 3, it will be 6. So our answer is 6. Another one is if we take 2 at a time out if letters A, B, C, if letters A, B, C, here A, B, B, A, B, C, C, B, and A, C, C, A. Here total number of arrangement is 6. Here if we take 2 out of 3, we can write 3 permutation 2. Our answer will be 6. And now another example is if we take 1 at a time out if letters A, B, C, then it will be here A, B, C. If we take 1 out of 3, 3 permutation 1, it will be 3. It will be 3. Another thing is here for permutation, arrangement and order is the mandatory part of permutation. Now factorial. Factorial is denoted by symbolic sign like this. Here this one, and another one is like this. Here this is called factorial. Suppose factorial n, it's called factorial n. Not n factorial, it's called factorial n. Suppose here factorial n equals to 1 into 2 into 3 into 4 and so on n, which is the ascending order, and another one is n into n minus 1 into n minus 2 and so on. Here 3 into 2 into 1, which is called descending order. So we can write factorial n like this way or like this way. For example, if we write factorial 5 equals to 1 into 2 into 3 into 4 into 5, and factorial 4 equals to 1 into 2 into 3 into 4, and here if we divide factorial 5 by factorial 4, so our answer will be here 5 into factorial 4 and denominator factorial 4. So here factorial 4 and factorial 4 will be cancelled, so our answer will be 5. Here another one is here 10 factorial divide factorial 10 divide factorial 5, so our answer will be here 10 into 9 into 8 into 7 into 6 into factorial 5, and here denominator will be here factorial 5. So here factorial 5 and this factorial 5 will be cancelled, so our answer will be 10 into 9 into 8 into 7 into 6. Now some theorems related to permutations. Formula number 1, the value of NPR, that is the number of permutation of n objects taking R at a time R to determine, where n and R are positive integers and n is greater than equal R. So we can write NPR equals to factorial n minus R. Now prove that NPR equals to factorial n by factorial n minus R. So here we can write NPR equals to n into n minus 1, n minus 2 and so on up to factor R equals to, here n is first factor, n minus 1 is second factor, n minus 2 is third factor, and up to factor R. So we can write here n into n minus 1, n minus 2 and so on. Here n minus r minus 1, which is number of r factor. So here n into n minus 1, n minus 2, and so on. We can write here n minus r plus 1. Now multiply by numerator and denominator by n minus r and so on, 3 into 2 into 1, and denominator here n minus r, 3 to 1. So here n into n minus 1 and n minus 2 and so on, here n minus 2 up to 1. So we can write here factorial n, and denominator is here n minus r and so on, 3 into 2 into 1. So it will be n minus r factorial. So n pr equals to factorial n minus r. Proved. Now formula number 2. The number of permutation of n different taking all at a time could be determined by putting r equals to n in npr equals to factorial n by factorial n minus r. So we can write here np r equals to factorial n minus r. If we put n pn, here n is instead of r, so here we can write factorial n minus n factorial. So it will be factorial 0 factorial n. All we know that factorial 0 is 1, which is special convention. Here we can write factorial n divide 1. So our answer will be factorial n. Our answer will be factorial n. Again, now formula number 3. Here we can write npr equals to factorial n by n factorial n minus r. If we put r equals to 0, here n p 0, so here factorial n minus 0. So our answer will be here factorial n divide factorial n equals to 1. Suppose here 7p0, our answer will be 1. So here if r equals to 0 and any kind of value n, our answer will be 1. Here 7p0 equals to 1. Again, if r equals to 1, then we can write np1 equals to, here our formula will be factorial n divide factorial n minus 1. So we can write here n into n minus 1, and denominator will be factorial n minus 1. So here numerator and denominator n factorial n minus 1 will be cancelled, so our answer is n. Suppose here 11 p1 equals to 11. Our answer will be 11. So we can write here, if r equals to 1 and for any kind of value n, our answer will be n. So we can write here r equals to 1, so our answer will be 11. Again, if r equals to n, here npn, then our answer will be here factorial n minus n. So here factorial n by factorial 0. All we know that factorial 0 is 1, which is the special convention, and here factorial n, so answer will be factorial n. So if r equals to n for and here npn, so our answer will be n factorial. Again, if r equals to n minus 1, suppose np n minus 1, so we can write here factorial n divide n minus n plus 1 factorial. So here factorial 1 factorial n equals to factorial n. Suppose here 7 p6, so answer will be here, answer will be here 7 factorial. This type of formula, which is very important for our MCQ test and for mathematical problem. Now formula number 4. If each thing is repeated up to r times in any permutations, then the number of permutations of n different things taken are at a time equals to n to the power r. Here n is fixed. For example, how many ways could 7 letters be thrown into 3 post box? Solution, we can write here number of post box equals to 3 and number of letters equals to 7. But one thing, multiple letter could be thrown into one post box, but one letter could not be thrown into multiple post box. That's why here post box is fixed, so we can write letters thrown into equals to here post box equals to 3, which is fixed 3, and here r equals to 7. So we can write 3 to the power 7. So our answer will be 3 to the power 7. Here 3 is fixed and 7 is changeable. Now formula number 5. The number of permutations of n such things when p of them are alike of one type, q of them are alike of second type, r of them are alike of third type, rest are all different, equals to factorial n divide factorial p into factorial q into factorial r. This is the formula. Now for example, find how many arrangements could be made with the letters of the word mathematics. So the word is here. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here total number of letters equals to 11. And two types of m here, and two types of a and two types of t. So total number of arrangement will be here numerator is factorial 11 and here factorial 2 and factorial 2. Which is the required solution of question number? Which is the required solution of this question? Now formula number 6. The number of cyclic permutations of n things taken all at a time equals to factorial n minus 1. So the formula is factorial n minus 1. Now for example, 7 girls will stand in circular form. How many ways could they stand differently in a circular form? Now solution. Here with one girl fixed, here with one girl fixed because of cyclic permutation. So the remaining 6 girls, could be able to stand in circles individually So now we can apply this formula. Here total number of girls here 7, so here n minus 1, so it will be 7 minus 1 here. So our answer will be factorial 6. Now formula number 7. If the cyclic could be seen from up and down and by overturning, then the number of permutations equals to factorial n minus 1 by 2. For example, in how many ways could 8 different pearls be strung on a band so as to form a necklace? Solution. Here one pearl will be fixed. One pearl will be fixed, and again clockwise and anti-clockwise distinction for the necklace are not taking differently. That's why 2. So now we can apply this formula for this type of math. So arrangement equals to here 8 minus 1 by 2. Factorial 8 minus 1 by 2. That's mean factorial 7 by 2, which is the required solution of this type of this math. Thank you to all.